Browser history. You have a browser of one tab where you start on the home page and you can visit another URL. Get back in the history number of steps or move forward in the history number of steps. Implement the browser history class. Initialize object with the home page of the browser. Visit URL from the current page. It clears up all the forward history. Back, move steps back in the history. If you can only return X steps in the history and then steps greater than X, you will return only X steps. Return the current URL after moving back in history at most steps. Forward, move steps forward in history. If you can only forward X steps in the history and the steps greater than X, you will forward only X steps. For this example, first, the home page is Leetcode. From Leetcode, we visit Google, and then from Google, we visit Facebook, and then from the Facebook, we visit YouTube. So in this case, let's write down that sequence. So start with homepage, Leetcode, and then next is Google, and then the next is Facebook, and then the next is YouTube. And then now we're at YouTube. We need to we move back to Facebook. This is where our cursor is. And then we move one more step back. From Facebook, we move one more step back to Google. And then from Google, we move forward to Facebook. This forward one. And now you're at Facebook, and then you are trying to visit LinkedIn. So in this case, visit LinkedIn, remember, when you visit, it clears up all the forward history. So in this case, you are at YouTube, and you are at Facebook, and you are going to visit LinkedIn. So in this case, it erases this forward history, YouTube, and then the next one will just be LinkedIn. And then you forward to, because you are in LinkedIn, you cannot move forward any steps. And then back to, from LinkedIn, going back one step Facebook, two step Google. So you return Google. And then back 7 steps. From Google, you can only be back one step to Leetcode. So in this case, the return value would just be Leetcode. So now we understand the problem from this example. So now let's think how to solve this one. So the idea to solve it is still to use linked list. Why? Because we can actually move to the next one and then also move back to the previous one. So here, the natural idea is to use linked list. So let's write down this one. So it's doubly linked list. Why doubly? Because we can move forward and move back. So let's first code the node. And then node value, let's set it to 0, default value, and then previous none, and then next none, and then self.value is just this value. So this is our list node. And then let's define this browser history. So let's set self.current. So initially, it's the home page. So that's our starting point. So basically, this self.current denotes the current pointer, the current node we are actually at. And then we also need to denote the start and then also the end so that we can move back and move forward. So self left. So for this self current, let's say point to a node. So its node, the value should be home page. So in this case, the initial value should be just be none instead of 0. So I changed the default value for this node. So in this case, let's first specify left and right, and then insert the self current. In this case, its home page is the node value is home page. The previous node is self.left. Next node is self.right. And then self.left dot next is just self.current. Self.right previous is also. So basically what we are doing here, we use a left pointer and a right pointer. So it indicates the start and then the end of this doubly linked list so that we can move back and move forward and then know when we are hitting the boundary. And then this self current indicates the current node we are actually visiting. And then initially this is just the home page and then previous node left node and then the next node is self.right. And then we just properly linked them together to form a linked list from self.left, self.current, and then self.right. So that's this init does. And then visit. So basically we visit this URL from the current page. So previously we have the previous node and then previous node linked to self.current and then links to the next node. This is self-current indicates the current page we are visiting. Next is forward history, previous is backward history. And right now we are actually visit this new URL. So after visit, this would becomes the node URL. So basically after visit, this node URL becomes the new self.current. So let me do it this way. So basically right now, this is our self.current. So this is our self.current. And then after this visit, so basically we are visit this new node URL. And then right now, this new node becomes the self.current. So previously we got previous node, current node, and next node. And then this current node position, this node is just where the self.current is points to. And right now, we are actually visit this new URL from the current location. So after visit, this is our original current node. And then after visit, this new node URL becomes the new self.current. And then we clear all the output history, all the forward history. So in this case, this directly connected to, let's say, something self.right. So let me actually form this one as the complete linked list. So basically we construct a linked list in this example, and then so this is our linked list before we visit this URL, and then line 21 is linked list after we visit this URL. So now let's write a code to actually implement this. So in this case, let me think about how to write this one. So basically, we get a previous. Previous is self-current dot previous. And then this previous node. Basically, previous dot next should be the self dot. Okay. So basically, we connect this one. So basically, self dot current dot next is just this new node. It's node URL, and then the previous is self dot current. And then the next node is just self dot write. So let's set this to be our node. So self.current is just equals to the node. And self.current.next is just this node. We also need to break down the connection. Let me see. So previous self.current.next dot previous is just self.current. So now let me see. Do we need to set that to none? So this is how we insert a node. Basically, we created this node, and then this node's previous node is self.current. And then this node's next node is self.write. And then we also need to update self.write.previous. It's just this node. And then let's call this back function. So basically move to the left. So well, self.current.previous, and also this this steps greater than 0. Self.current is self.current.previous. And then steps. We decrease the steps by 1. And then we just return self.current.value. And then let's do the forward. For the forward, well, self.current.next the value, and then steps greater than 0, self.current. Steps return self.current.value. So let's run the solution. Okay, so this gives the wrong answer. So the wrong answer is visit. something wrong with the visit. Let me see if there's something wrong with visit or something wrong with. So the output is just Leetcode, right? So it kept the Leetcode browsing history and then back. Okay, the back should be Facebook, but it's still Leetcode. When we visited, oh, I forgot one thing when I write this visit. So I need to update the self-current. Self.current equals self-current.next. I need to update the pointer. So basically the step is, okay, I insert this node, new node, and then after that, I should update self.current. I forgot about that. So the solution is accepted. So let's recap the idea. So basically the idea for solving this one basically is some sort of history and move back and forward. So the idea is use doubly link the list. So we first created the list node and then we initialize starting position. The initial linked list is self.left, which is empty node, which is a dummy node, and then point to the node of the home page and then points to self.right. And then when we visit, so before we visit, we are at a state for the line 20. Our current node, where is the location of the self.current, and followed by next node. After visit, we insert this new URL after the current node, and then we update of our self.current to point to this newly visited URL. This is how it is done. We first initialize the node. So that this node value URL, previous node self.current, next node self.write, because we clear up all the forward history. And then after that, we also need to make sure its previous node's next node points to this newly inserted node, and then its next node's previous pointer points to this current node. After that, one step I forgot initially was to update self.current. And then for the back, so basically we just move to the left. So in that case, we need to check, okay, if the previous node, if we can move to the previous node, or if we have reached the steps, the number of steps. Similarly, for forward is we are checking if we can reach the next node, or if we have reached the steps. So this is our solution.